Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss 3 more multiple choice questions with only one correct option on thermodynamic processes. The questions are as follows. Question 1. An ideal gas, gamma is equal to 1.4, expands from an initial volume 5 into 10 to the power minus 3 meter cubed to a final volume 25 into 10 to the power minus 3 meter cubed at a constant pressure of 10 to the power 5 pascals. Then the heat energy absorbed by the system in the process is, the options are 700 joules, 900 joules, 4800 joules and 7000 joules. Question 2. A thermodynamic system undergoes a cyclic process whose PV diagram is shown in the figure. Then, in one cycle, the system, the options are, absorbs 314 joules, rejects 314 joules, absorbs 314 kilojoules, and rejects 314 kilojoules. Question 3. 1 mole of a monoatomic ideal gas is contained in an insulated and rigid container. It is heated by passing a current of 2 amperes for 5 minutes through a filament of resistance 200 ohms. Then the change in the internal energy of the gas is, the options are 120 kilojoules, 240 kilojoules, 300 kilojoules and 480 kilojoules. First, let us solve the problem in question 1. It is about the expansion of a gas at constant pressure. We are required to find the heat energy absorbed by the gas. For this, we will use the first law of thermodynamics. Delta Q is equal to delta U plus delta W. Now, delta W is equal to P into delta V, which is equal to P into V2 minus V1. It is given that the constant pressure P is equal to 10 to the power 5 pascals and volume changes from V1 is equal to 5 into 10 to the power minus 3 meter cubed to V2 is equal to 25 into 10 to the power minus 3 meter cubed. Also, gamma is equal to 1.4. Therefore, we have the change in volume delta V is equal to 20 into 10 to the power minus 3 meter cubed. This implies that delta W is equal to P into delta V, which is equal to 10 to the power 5 into 20 into 10 to the power minus 3, which is equal to 2000 joules. Now, the two specific heats of the gas are related as R is equal to Cp minus Cv. Dividing throughout by Cv, we get R by Cv is equal to Cp by Cv minus 1, which is equal to gamma minus 1. This implies Cv is equal to R divided by gamma minus 1. Now delta U is equal to N into Cv into delta T, where N is the number of moles and delta T is the change in temperature. Therefore, delta U is equal to Nr into delta T divided by gamma minus 1. Now, for an ideal gas, we have PV is equal to nRT. Differentiating, we get P into delta V plus V into delta P is equal to nR into delta T. As pressure is constant, we have delta P is equal to 0. Therefore, we have P into delta V is equal to nR into delta T. Therefore, equation 1 implies delta U is equal to P into delta V divided by gamma minus 1. We have already calculated P into delta V is equal to 2000 joules and gamma minus 1 is equal to 0.4. Therefore, delta U is equal to 2000 divided by 0.4, which is equal to 5000 joules. Therefore, heat absorbed by the gas is delta Q is equal to delta U plus delta W, which is equal to 5000 plus 2000, which is equal to 7000 joules. Therefore, the correct option is D, which is the answer to question 1. Now, we will solve the problem in question 2. The situation is shown in the figure. It is about a cyclic process for which we are required to find the amount of heat and whether heat is absorbed or rejected by the system. First, let us decide whether heat is absorbed or rejected by the system. The PV diagram for the process is clockwise. Therefore, the volume of the gas increases at higher pressure and decreases at lower pressure. Therefore, positive work done is greater than the negative work done. Therefore, the net work done is positive. Also, for a cyclic process, change in the internal energy delta U is equal to 0. Therefore, we have delta Q is equal to delta W, which is positive. Hence, heat is absorbed by the system. Now, delta W is equal to area enclosed by the PV diagram. We observe that the PV diagram is circular, but the horizontal diameter AB is equal to 20 kilopascals and the vertical diameter CD is equal to 20 liters, which is equal to 20 into 10 to the power minus 3 meter cube. Since the two diameters are not equal, the PV diagram is to be considered as an ellipse whose semi-major axis A is equal to 10 kilopascals, which is equal to 10 to the power 4 pascals, and the semi-minor axis B is equal to 10 to the power minus 2 meter cube. Now, area of the ellipse is equal to pi into A into B. Therefore, we have delta W is equal to 3.14 into 10 to the power 4 into 10 to the power minus 2, which is equal to 314 joules, which gives delta Q is equal to delta W, which is equal to 314 joules. Therefore, the system absorbs 314 joules of heat. Therefore, the correct option is A, which is the answer to question 2. Finally, we will solve the problem in question 3. It is about the electrical heating of an ideal gas at constant volume. We are required to find the change in the internal energy of the gas. Given that resistance of the filament R is equal to 200 ohms, current I is equal to 2 amperes, time for which current is passed T is equal to 5 minutes, which is equal to 300 seconds. Therefore, heat absorbed by the gas is delta Q is equal to I square into RT, which is equal to 4 into 200 into 300, which is equal to 24 into 10 to the power 4 joules, which is equal to 240 kilojoules. It is given that the gas is heated in a rigid container, therefore volume remains constant. Now, at constant volume, delta V is equal to 0, therefore we have delta W is equal to P into delta V, which is equal to 0. From the first law of thermodynamics, we have delta Q is equal to delta U plus delta W. Since delta W is equal to 0, we have delta U is equal to delta Q, which is equal to 240 kilojoules. Therefore, the correct option is B, which is the answer to question 3. This completes the answers to the questions.